Beneath the Geneva gloom, far below the world's surface, lies a stunning triumph of human ingenuity, and an inevitable harbinger of devastation. The Large Hadron Collider, or LHC, is an amazing feat of intelligent analysis that allows scientists to probe the subatomic realm, bringing about the discovery of the elusive Higgs boson, often dubbed the God particle. This innovation has captivated the scientific community. As renowned physicist Brian Cox once ominously declared, a potential hidden from view has been uncovered at CERN, sparking a wave of wonder and worry. Could our pursuit of knowledge have led us down a dangerous path? Have we set our course toward an uncertain future that defies our understanding? Before exploring this startling possibility further, it's essential to first take a look at the gigantic machine that is the Large Hadron Collider, operated by CERN. The LHC is a massive 17-mile superring of conducting magnets and is by far the strongest and largest particle accelerator ever built. It stands as the pinnacle of scientific achievement, capable of recreating circumstances that rival the universe's very creation. This amazing equipment allows scientists to explore the fundamental components of the cosmos, but with such power come unanticipated effects, possibly even terrifying ones, into uncharted territory. With its roots in 1954, CERN has become one of the world's most important and prestigious research centers, with 23 member countries and a vast network of experts. While the LHC is only the most well-known, it is part of an expansive array of accelerators and detectors aimed at comprehending the smallest components of the universe. The LHC is a race to uncover the very foundation of existence. It accelerates protons to nearly the speed of light, causing them to collide, simulating the energy and conditions of the universe at its inception. The temperatures produced are millions of times hotter than the sun's core, while a complex network of magnets directs these particles along their course. Simultaneously, highly sophisticated cooling systems maintain extremely icy surroundings, far colder than even outer space. The LHC is equipped with 1,232 directional dipole magnets, 392 quadrupole magnets, and protons that focus the beam just before they collide. Another crucial type of magnet helps increase the probability of collisions by pushing particles together with incredible force. CERN's objective is to collide particles with such precision that it's akin to hitting two needles placed 6 meters apart. The precision required for this operation is mind-boggling, and the level of technology involved is unparalleled. The collider's construction features deep underground, concentric rings that protect them from radiation. In order to attain optimal performance, the entire system is cooled to -456 degrees Fahrenheit, colder than the vacuum of space. This underground setup houses 4 distinct particle detectors, ATLAS, CMS, ALICE, and LHCb, each with a unique purpose in investigating various aspects of particle physics. These massive sensors include cameras that capture particle impacts, with experts constantly searching the data for traces of the elusive Higgs boson. The Higgs boson is thought to be integral to understanding the very fabric of the universe, offering insights into its fundamental structure. In numerous ways, studying the microcosm helps us unravel the macrocosm, solving a massive, cryptic jigsaw puzzle. However, with each piece we place, new questions and mysteries emerge, reminding us that every discovery leads to another challenge. The LHC is more than just a scientific tool, it is an embodiment of human ambition and the unwavering determination to comprehend the fundamental forces that shape our universe. But once we enter the unknown, we must also confront the moral and existential dilemmas that accompany such brave investigation. What are the potential risks of delving into the unseen? Could our quest for understanding unleash forces beyond our control? Recently, a disturbing revelation has shaken the scientific community. Brian Cox, a former researcher at CERN and a prominent figure in the field of particle physics, made a statement that has both piqued curiosity and frightened his colleagues. According to Cox, the LHC's goal of recreating a miniature version of the Big Bang, reproducing the very event that gave birth to our universe, could lead to unforeseen consequences. The collider's impressive ability to investigate the depths of the Higgs boson and explore the enigma of dark matter, a substance that makes up a significant portion of the universe, could potentially reveal information beyond our comprehension. While the concept of locating the universe's darkest mysteries is exhilarating, it is also fraught with risk. The LHC recreates extreme circumstances that simulate the inception of the universe, temperatures, pressures, and energies unlike anything observed in daily life. It's like looking through a window into the moment the universe began. Yet such immense power brings with it immense responsibility. Consider the incident involving Russian physicist Anatoly Bugorsky in 1978. Bugorsky was conducting research at the U-70 synchrotron at the Institute for High Energy Physics when a tragic accident occurred. A proton beam accidentally penetrated his skull, causing significant tissue damage. Remarkably, he remained conscious and walked to seek treatment. His experience serves as a stark illustration of the potential dangers associated with the power harnessed by particle accelerators, power that should never be underestimated. Concerns about the LHC's capacity to create black holes, albeit on a very small scale, have raised alarms among some in the academic community. Black holes are regions of space with such intense gravity that not even light can escape. Some scientists have expressed concern that the LHC might create a miniature black hole, one that could theoretically consume the Earth from the inside. While CERN researchers have reassured the public that any black holes generated would evaporate almost instantly and pose no threat to the planet, this theoretical possibility has still sparked curiosity and fear. The idea of a black hole being created by collisions of high-energy particles has been widely debated and has added to the growing awareness of the risks involved in such powerful experiments. Understanding the mechanisms of the LHC is essential for comprehending its potential to form a black hole. When protons accelerate almost to the speed of light and collide, the energy produced is so immense that it distorts the fabric of space-time itself. This effect could be compared to jumping on a trampoline and bending the surface. These distortions raise the unsettling question: could such shifts lead to the formation of a black hole? In the strange and mind-bending world of quantum physics, where the universe's fundamental laws often defy logic, some theories suggest that unknown aspects of reality may be hidden within the fabric of space. If such elements exist, the LHC could potentially tap into them, triggering the development of a gravitational anomaly capable of forming a black hole. As the world watches CERN's experiments with a mix of awe and apprehension, a broader philosophical question begins to emerge: should everything that is scientifically possible also be pursued? The Large Hadron Collider may help us answer some of the most profound questions ever posed, about the origins of matter, the possibility of parallel dimensions, or the true nature of time. Yet each discovery forces humanity to stare deeper into the abyss of the unknown. And within that abyss lies not just theoretical marvels, but the potential for existential risk. One of the most startling and controversial theories arising from particle physics involves extra dimensions. According to certain interpretations of string theory, the universe may contain up to 11 dimensions, most of them curled up in microscopic scales, imperceptible to us. The LHC, by reaching unprecedented energies, may be the first device capable of peering into these hidden dimensions. If such dimensions do exist, the consequences could be staggering. Not only would this revolutionize our understanding of gravity and cosmology, it might also expose us to phenomena we are not yet prepared to handle. Some theorists propose that if particles can escape into these extra dimensions, energy might not be conserved in the way we understand it. Such leakage could signal the beginning of a gravitational collapse, or the birth of a micro-black hole that defies current containment theories. Another concern is rooted in the idea of strangelets, hypothetical particles composed of strange quarks. If even a single stable strangelet were accidentally created, it could, in theory, convert surrounding matter into strange matter, spreading like a virus through the atomic lattice of the Earth. While mainstream physicists view this scenario as nearly impossible, it is not deemed entirely inconceivable. The sheer scale of what the LHC is doing, manipulating conditions not seen since fractions of a second after the Big Bang, demands not only technical rigor but philosophical introspection. Are we the explorers, or are we the invaders? What if the cosmic code is not meant to be rewritten? Even if catastrophe is avoided, what lies beyond the veil may be no less unsettling. If the LHC does discover evidence of dark matter particles, elusive material that composes approximately 85% of the universe's mass, it could transform our understanding of physics entirely. But what if dark matter isn't inert? What if it interacts in ways we've never imagined? Could we be poking at something that is not meant to be disturbed? And there are stranger speculations still, those that blend science with myth and theory with cosmic warning. Some have speculated that the high-energy collisions at CERN could, under incredibly rare conditions, create phenomena reminiscent of ancient prophecies, portals, time distortions, or anomalies that mirror descriptions from religious or esoteric texts. While such claims are widely dismissed as pseudoscience, their emotional impact speaks to something deeper, the primal human fear of tampering with the fabric of creation. Indeed, history shows us that great scientific leaps often outpace society's readiness to deal with their consequences. The splitting of the atom, once hailed as a triumph, eventually gave birth to weapons of unimaginable devastation. Could the secrets unlocked by the LHC, if misused, misunderstood, or unleashed prematurely, lead to consequences even greater? For now, CERN continues its experiments, cautiously, meticulously. The scientists are not madmen in a lab, they are some of the most brilliant minds on Earth, working with precision, integrity, and care. But no system is perfect. No human endeavor is immune to accident or oversight. And in a machine where a tiny miscalculation could alter the laws of the observable universe, perfection is not just a virtue, it is a necessity. So, as we stand on the precipice of possibility, we must ask ourselves not just what we can discover, but what we are willing to risk in the process. The LHC may hold the key to unlocking the deepest truths of our existence. But it may also be the doorway to questions that have no answers, and consequences that cannot be undone. And so, beneath the earth in the heart of Europe, the great machine hums on, driven by the pursuit of truth, guided by science, haunted by the specter of its own potential. Because when we open the door to the origin of all things, we must also be prepared to face whatever steps through. Humanity pushes the boundaries of knowledge. The LHC's scientific discovery is still an exceptional illustration of our desire to understand the universe. The sheer scale of the project reveals a great deal about the over 10,000 aims behind it. Technicians, engineers, and scientists from all over collaborate with CERN to ensure the success of the machine. The scale of the data collected by the LHC is overwhelming. With experiments that produce petabytes of data every year, the storage and processing power needed to deal with this colossal quantity of data demand cutting-edge technology. This has revolutionized fields like computer science and data science. The experiments at the LHC go far beyond particle physics, extending into areas like material science and even medicine. Studies in the environment, or the study of the Higgs boson, for instance, could have wide-ranging implications beyond our comprehension of the universe. The Higgs particle, a fundamental part of the standard model of particle physics, is essential in giving other particles mass. Without the Higgs field, the universe would be vastly different, with scattered particles in a state devoid of cohesion. Beyond fundamental comprehension, scientists are eager to understand how the particle behaves under extreme conditions. These studies could result in important insights into everything from the development of new materials to understanding the fundamental factors that determine the nature of the universe. Another important aspect of the LHC is its exploration of the invisible substance known as dark matter, a substance that accounts for around 27% of the universe's mass energy content. Despite its immense presence, scientists have not yet directly detected dark matter. It remains a key focus of the LHC's experiments. By observing the behavior of particles created during high-energy collisions, researchers hope to expose the conceivable particles that may consist of dark matter. If dark matter is finally identified, it might alter the way we perceive the universe, unveiling hidden dimensions of space-time and altering the foundations of modern physics. Alongside dark matter, the LHC is also looking into other exotic realms, such as supersymmetry and the potential existence of extra dimensions. A theory called supersymmetry suggests a relationship between two basic classes of particles, bosons and fermions, and predicts the existence of superpartners, particles that have not yet been observed. The discovery of supersymmetry could open the door to a fresh perspective on the fundamental forces of nature, providing a deeper understanding of the interactions that control our environment. Additionally, the LHC is essential in advancing quantum computing. By comprehending subatomic behavior, researchers can gain valuable insights that have the potential to transform how we process quantum information. Computers operating in accordance with quantum mechanics have the potential to solve problems that are currently beyond the reach of classical computers. Technologies created specifically for the LHC's experiments, including specialized sensors and cutting-edge computing algorithms, have already influenced the field of quantum computing. Despite its limitations, this represents a path to future breakthroughs. The unquestionable advantages of the LHC's work also raise fundamental questions about humanity's future. The search for the unknown can be exhilarating, but it also comes with the obligation to consider the possible unintended consequences. The technology that drives the LHC could potentially be used for purposes that harm humanity, such as the development of advanced weapons or the creation of ethically controversial scenarios. Ethical debates surrounding the LHC are not limited to the risks of catastrophic events like black holes or vacuum decay. They also include the potential application of the research itself. How can we ensure that this knowledge is used responsibly, and that the search for truth does not inadvertently lead to harm? As we explore the unknown, it is crucial to engage in ongoing discussions regarding the equilibrium between scientific progress and ethical responsibility. The fact that the LHC's work requires cooperation from multiple nations, each with its own values, priorities, and concerns, makes transparency, accountability, and international collaboration essential in ensuring that the knowledge gleaned from these experiments benefits humanity as a whole. Through the LHC, CERN's efforts serve as a reminder that scientific success must always be balanced with careful consideration of its broader consequences. Another issue of concern is the potential for unforeseen ecological effects. While the LHC is relatively small in physical size, it is not devoid of environmental impact. The enormous energy requirements of such machines are worth noting. The environmental footprint of particle accelerators, especially those requiring massive amounts of electricity and creating heat, could strain natural resources and ecosystems. The energy demands of the LHC are immense. Despite efforts to use renewable energy sources and improve efficiency, the broader question of sustainable scientific exploration must still be addressed. In the end, the path forward will necessitate a delicate balance. The LHC represents humanity's desire for knowledge, exploration, and discovery. However, as with all scientific breakthroughs, this necessitates ethical reflection and responsibility. The risks involved in such experiments cannot be ignored, but the potential rewards could restructure our perception of the universe in ways we can only begin to imagine. As we move forward on this journey into the unknowable, we must ensure that scientific progress is conducted in a way that is secure, responsible, and beneficial for future generations. In conclusion, the Large Hadron Collider is far more than just a tool for scientific discovery. It is a symbol of humanity's quest for knowledge and the endless curiosity it inspires about the nature of existence. The LHC's work has raised profound and significant concerns, existential and moral alike. However, it also demonstrates that by working together and exercising careful oversight, we can uncover secrets that have the capacity to alter the course of history. As we stand on the precipice of these brand new findings, we must remain vigilant, mindful of the potential risks, and committed to the ethical use of the knowledge we uncover. In the end, the quest for understanding must always be guided by the obligation to protect our future. This commitment to protecting the future does not imply halting progress. Rather, it emphasizes the need to align innovation with integrity. The LHC, as a beacon of scientific ambition, sets a precedent, not only in terms of technological achievement but also in the responsibility that must accompany discovery. One of the most powerful messages the LHC conveys is that science, when pursued collaboratively and ethically, can become a unifying force for humanity. The participation of nations with diverse political systems, cultural backgrounds, and scientific traditions underscores the possibility of cooperation even in a fragmented world. In a time where division often defines global discourse, the shared mission of discovery reminds us of our common origin and shared destiny. Moreover, the LHC illustrates how large-scale scientific projects can stimulate education, inspire future generations, and drive socio-economic development. Thousands of students, researchers, and educators are connected through its research, forming a global network of knowledge exchange. These opportunities not only advance scientific understanding but also cultivate critical thinking, innovation, and international solidarity. As new particles are discovered, and as theories evolve or are dismantled, the work at the LHC forces us to redefine what we know, and what we thought we knew. Each discovery is not a final answer but rather an invitation to ask better questions. In this sense, the LHC is not merely a machine but a philosophical compass, guiding humanity through the deepest corridors of existence. Yet, we must remain cautious. As the boundaries between theoretical possibility and practical application blur, so too does the line between benefit and danger. The dual-use nature of powerful scientific tools, capable of both healing and harm, demands that ethical frameworks evolve alongside scientific capabilities. Moving forward, it is imperative to embed ethics into the very fabric of scientific endeavor. This means developing international policies that not only regulate experiments but also anticipate their wider impact. It means ensuring that the benefits of discovery are shared equitably, not hoarded by the powerful or weaponized for control. In the final analysis, the legacy of the LHC will not be defined solely by the particles it discovers, but by how those discoveries are used. Will we create a world more enlightened, more connected, more just? Or will we allow knowledge to become a tool of division, fear, or destruction? The answer lies in our collective hands. The LHC offers us a lens through which we can peer into the origin of everything, but it also reflects back to us the image of who we are, and who we choose to be.